Good morning, guys. I'm going to make a video presentation again on a four-hull vessel, which is a Nara, and it's going to load cargoes 1, 3, and 4 at the same time discharge ballast. And what will be his final drop upon completion and his stream. So we'll do this by computation, also with backup program. So we'll just compare this one by one to give you a guidance on what to do. Okay, so start, guys, and I'll start with this. Okay. Put this a little bit bigger, and a little bigger. Okay. So here's the problem. MB Nara present. Okay. This is present. Put S here. Present drop forward is 7.60 meters and drop up is 8.95. And dock water density is 1.017. So it's loading at berth. So it's going to load number 1, 3, and 4 of number 1 is 3,000 metric tons. Number 3 is 3,000 metric tons, and number 4 is 2,000 metric tons. Number 3 is 3,500. Now he's going to discharge ballast in number 1 forward. This should be negative because he's going to discharge. Okay, when you say negative, that is to discharge. Okay, put here discharge, all discharge. Okay, that's why you put here negative and negative. Okay, so when you discharge in a program, we put this one negative, and this one is the LCG, this is the weight, this is the weight and LCG. Okay, so number 1, first procedure. By the way, this is the program, how to find draft and trim when handling weights involving large changes in wind draft. So we just follow these procedures manually, and this one by program. So number 1, you put the drop and the density and the updraft. So your mean will be 8.28 and the trim is 1.35. Okay, put this like this. Make it, did you see it like this? Okay. 1.35. In our program, manual computation. So we have here forward is 7.6, up is 8.95, your main drop is 8.28, and your trim is 135. So in number 2, the main drop, which is 8.28, this is should be dock water. Okay, because the density is 1.017. Okay, so dock water because your density is 1.017, and we'll be looking for LCF. Okay, LCF. Okay, what's the LCF is number 2 is only LCF. Okay, our LPP is 151. So that's number 2. You only look for LCF. So in number 2, we're just looking for the LCF is 155. But according to the program, is LCF is 155. So I already run it up. Okay, so we go now to number 3. correct the main drop to main drop, correct the main drop to main drop at center of rotation. So this is the formula, and the main drop is 8.289, number 3, okay? So in number 3, we go to number 3, scroll down, and this will be number 3, okay? So mid drop center of rotation is trim times LCF over LPP plus your mean drop, okay? It is the same here, is your trim times your LCF over LPP plus your mean drop. This is your mean drop. To correct the mean drop. Corrected mean drop. And let's proceed. So the formula is trim times LCF over LPP plus mean drop. So I put here the trim, and your LCF is 155, which is this one, okay? So transpose your trim is 135, okay, and your LCF is 155 over your LPP. LPP is 151, okay? I put here LPP, so that will be 151, okay? Put this way. Copy LPP. Okay. 151. Okay. Just numbers lang. Enter. Okay, so the suppose trim is 135, your LCF is 155 over your LPP 151, and your mean drop is 828. Okay, so multiply this one, then you will have 2.0898 over your LPP. Okay, so your LPP divide this one, that will be equals divide by your LPP, that will be 0.14. Okay, then the next with this figure, okay, we do this one to make it clear. 1.35 times LCF equals, okay, then this value divided with your LPP, that will be here. This one divide your LPP. Okay, make this a little bit longer. Then you add this one with your mean drop. That will be, this one will be here, and that will be equals this one plus your mean drop. Mean drop is this one. Okay, that will be 8.29 is mid center of rotation. And what did the program here is 8.2810. I've already run off. So we go to number 4. Number 4 says, using the MV draft of rotation, take the hydrostatic table, the corresponding displacement, LCB, MTC. So only displacement, LCB, MTC. So displacement, LCB, and LTC. Okay. So from the displacement of number 4, this number 4, the displacement of 829 should be 26445. The program says 26444, but I got 245. Okay, we got 8289. So 8289, static table. We get 8275 from, okay, what we do, put it like this. Once, sorry, this one here, and here, and check for the, sorry, for the displacement 26445. Displacement na I got 26445, and LCB is 3.85. LCB is 3.84. Okay, I just 3.84, and your MTC is 2584. MTC is 245, but 245, 258. Okay, what I have here, okay, put this one, should be MTC is 25838. 25838 should be 25838 already, 258.4, which is already run up to 4, but I have 2538, and LCB is 3.85. LCB 3.85. Okay, that is in number 4. And number 5, you look for the initial LCG. The trim is, the formula is trim times MTC times 100 over your tabulated displacement plus LCB, and the resultant will be 5.16831. That will be number 5. So you go to number 5. This is number 4, then we go to number 5 here. Okay. Your trim is Your trim is 1.35, this one, times MTC. MTC is 25838. Okay, that is already rounded to 4 times 100. And tabulated displacement is 26445. I got here 26445, okay? Plus your LCB. What is your LCB? LCB is 385. 385, okay? Multiply this one. Put equals trim 135. Click this one times your MTC, which is this one, and click this one, MTC times 100 equals, okay, that will be of this one. Then you put your tabulated displacement of 26445, which is this one, and your LCB is 385. LCB is 385, okay. Divide these two, that will be equals, divide this one, and, oh, I'm sorry, equals this one, divide this one, equals, that will be 1.31904. You add this with your LCB, that will be equals, click this one, plus your LCB. LCB is this one, 385, equals, your initial LCG is L 5.1690. So your initial LCG is 5116831. 5116831. I got 516904. Okay, that is your density of 1.017. Okay, because you are floating in a density of 1.017 in this operation, loading and unloading of ballast. Okay, that will be number 5. So we go to number 6. We go to number 6. What is number 6 here? Correct the displacement to true displacement, initial displacement, by applying the effect of density. So the density in this will be salt water of 26238.1. This will be salt water. This is the formula. So the displacement multiplied with your local density over 1.025. So DD is your dark water density. So number 6. Number 6. This is your local density, right? So your displacement, what is your displacement, is 26445 times your, this one, 26445, which is your displacement times your local density of 1.017, okay, which is this one, and over your 1.025 or seawater. So multiply this one over 1.025 is 26238. It's got 26238. 26238 is got 26238. Okay, almost the same. To give you the exact computation, put this equals. Okay, so equals. Click your displacement, then times your local density of 1.017. This one, okay. That will be, so you put it this way, put here sum, open, then you close parenthesis over or divide by 1.025. 1.025. You see the formula here? Then press enter. That will be 26238, okay? 26238, and you have 26238. That is your initial displacement. Take note that your initial displacement automatically put is here in the weights, and your initial LCG is automatically put here above. Okay, again, once you get your initial displacement, you put it here. That will be your weights, and your initial LCG will be here. Okay, then you put all the weights of 1, 2, 3, 4. Put the LCG and the ballast. Okay, put it here and put the LCG, and the total displacement will be 33068.1, and your LCG is 4.020469, and your total LCG moment is 13295.6. Okay, this will be your final LCG. This one, final LCG. In the program, so that is number 7. Okay, take note that the weight I have is 26238, which is 26238. Okay, and the final LCG is initial LCG is 51169, which is this one. Okay, then you put all the weights, ballast here, put all the weights and your LCG here, because you're discharging ballast, that's why it's negative, and that's why here. And this is the LCG for each compartment, and put the holds to be loaded, which is 1, 3, 4, and corresponding weight, that will be this one. Okay, so with your displacement multiply with your LCG, this will be your total, this will be LCG moment. This value of ballast times your LCG. What's your LCG moment? This figure multiplied with your LCG, this will be your LCG moment, and so forth until completed in number 4 hold to 2000 multiply with your LCG, that will be this value. Total altogether, and your total, this is your final displacement. Okay, it can be your final displacement. Okay, will be this one, 33068, and your total LCG is 138.132.975.616. Okay, take note, this will be your total LCG, and this will be your displacement. To get the final LCG equals your L total moment divided with your final displacement, which is this one, 132.975, divide with your displacement of the 0.68, and your final LCG will be 4.021, which is this one. Okay, and the program is final LCG is 402069. 4.02069. I got 4.021. Okay, already run off. That is your final LCG. Then we go to number 9, which is look up displacement to convert this one to your, because this displacement is salt water. Okay, take note. This one is salt water. Okay, just you will understand better. This one is salt water. Okay, this is salt water. I'm sorry. Yeah, that is salt water. And you convert this with your, you apply the density of 1.017. Okay. And number 9, it says here, go to number 9. Correct the final displacement to look up due to the effect of density to find the mean drop. Look up displacement, final displacement times your salt water over your local displacement. And number 9 would be 33328.25. Okay, you apply this density, and number 9 would be this one. Number 9. Okay, this is your DD or your local density. So displacement times 1.025 over your local displacement, or 33068, which is this one. 33068 times salt water 1.025 times your local density of 1.017, that is your DD. So multiply please these two first, your local displacement times 1.025. So multiply equals, click this one, times, okay, times 1.025 0.25, this one. You press enter. That will be 33894.8. Divided with your local density, that will be, okay, equals. Click this one. Divide your local density, and that will be 3328.2. 3328.2. That will be 3328.25 or 0.2. And the corresponding drop with this one is 10.23. So with this displacement, you can put it here. So we put here equals. Then you click. You click this displacement. Then it will go here. Your corresponding drop will be 10.237, which is this one. Okay, that will be number 10. So number 10 is using the corresponding displacement, take the hydrostatic table, takes the drop of LCB, MTC, LCF, and TPC. Okay, so these are the value. This is the value of this drop of LCF, TPC, LCB, and MTC, and this one. Okay, so in the manual, since you already your displacement, what will be this drop will be, that will be 10.23. Okay, that will be here 10.23 as in this one. Okay, so this is the drop. What is your LCB? LCB is 295. LCB is 295. LCF is 0.273. Negative 0.273. And here negative 0.27. MTC is 37982. 37982. 37982. And TPC is 3593. TPC is 3593. It is also the same here. Okay. Negative 027. Negative 027. LCB is 2953. 295. And your MTC is 37982. 37982. 37982. And your TPC is 3593. TPC is 3593. So this same. Check. Then we go to 11. Okay, we go to 11. Find the trim after loading or discharging your final trim. So this is the formula: LCG minus LCB times corresponding displacement over MTC times 100. So you're now looking for the final trim. It doesn't show here, but here manually I will show you. That will be number 11. Okay. So this is the values that we got a while ago. Then we go to number 11, the final trim or your corrected trim. Change of trim or final trim. So displacement times final LCG minus LCB over MTC times 100. Okay? Transpose now. Your final LCG is 0.02, okay, which is this one. Final LCG is this one, okay. So your final LCG is this one, 0.021, okay. Your LCB is 295, okay, 295, and your displacement is 3328 over your MTC is 37982, which is 37982 times 100, okay. First, we minus this one, final LCG minus LCB. So your final LCG is 402 minus your LCB of 295. That will be 1.05, 1.07. Put it here. Once you have already this value multiplied with your displacement, okay? And your MTC times 100, that will be this value. So this one, you put equals displacement times 1.07 equals the value, and your MTC put equals your MTC times 100, that will be this one. Divide this all together equals this one divide by this one, and resultant will be 0.94. This will be your trim, corrected trim or change of trim. And the program trim is 0.937 or 0.94. Okay, that is number 11, this one. Then you will have to take your you will look for change of drop forward and change of drop up, and this is the formula. LPP, 1/2 of LPP plus LCF over LPP times your final trim. This is your final trim, okay? So we do that in the computation. So first you will get the change of drop forward. So 1/2 of LPP, your LPP is 151, and 1/2 of 151 is 75.5, and your LCF is negative 0.27. LCF is this one, negative 0.27, okay? And your trim is 94, okay? So transpose 1/2 of LPP is 75.5 plus your LCF of negative 0.27 over your LPP is 151, okay? Times your trim of 0.94, okay? First you add this one, that will be here. 1/2 LPP is 75.5 plus your LCF of negative 0.27, and that will be the value. Divide it with your LPP, that will be equals, click this one, divide your LPP, and that will be 0.49842. Multiply with your trim, equals, click this one, times your trim, and change of drop forward will be 0.47, and your change of drop up is trim minus your change of drop forward is this one. So trim of 0.9794 minus your 0.47 or your forward trim is 0.47. So you click, okay, click this one, your trim minus your change of drop forward, and your change of drop up will be 0.47. Okay, so you have now your change of drop forward and change of drop up. Okay, then you go down, put your hydrostatic drop or your mean drop, which is this one, which is this one of 10.027, because this is corresponding displacement of 3328, which is this one. Okay, I'll go up, show you. So with this displacement, this is your corresponding mid drop of 10.237. So you put here forward drop of 10.237. This will be, you could put this like this if you want. Okay, like this. Apply your change of drop forward, change of drop up. You add this one, subtract, then you will have forward be 9.77, up will be, you add the change of drop, then you have 10.71, which is, your forward is 9.77, up is 10.71, and your final drop is, forward is 10.77, up drop is 10.71, and your main drop is 10.24. 9.77, 10.71. So you got here 9.77 and 10.71. Then another solution, with your mean drop, subtract your change of drop forward, then your forward drop will be 9.7, plus your trim of 0.94, then your up drop will be 10.71. So this will be your mean drop, okay? Mean drop. That you will not get lost, okay? Okay. So you have here, forward 9.77, up is 9.71, mean drop is 10.24, your trim is 94, which is the same with this one, okay? Now, take note guys, take note of this hold number, take note of this cargo. In number 1, you load only 3,000, but in number 3 and 4, you will load about 5,000, meaning you will have more drop up here because you have more cargo in your 3 and 4. So which means you will be trimmed by the stern because of this analyzing this cargo, okay? Now in the ballast, when you say your LCG is negative, that will be in the forward part of the vessel. So look, negative, you have more ballast or weight of ballast in the forward to be discharged. If you take out ballast in the forward part, which is one, take out ballast here and take out ballast in number 1 TST, the tendency of the forward part will rise up, okay, and this will go down, meaning you will have a trim by the stern. So just analyze this one. The forward part of your vessel, which is number 1 WBT, number 1 WBT. If you take out ballast of 820, the tendency of your forward vessel is to go up. Plus, you have also to take out 400 here ATST, number 1, which is also negative. It will rise up more. On the up part, you have more cargo in your hold number 3 and 4. Of course, this will go down. That's why, if this goes down, the up part, the forward part will go up. Okay? That's why you have more ballast, more drop in your up. That's why your drop is 10, you have more drop up of 10.71 and forward is 9.77 and your trim is 94. And another way of looking at it is by using the value of your LCG and LCP. Okay, take note. Okay, how much is your take note, your LCG is 4.02. So 4.02, this should be what you have plus. Should be chart. Wala mo rin yung code. Chart. Okay, from if this is your amidships, make sure from amidship going forward is negative. From amidship going backward is positive. Okay, since your forward LCG is positive, so it is measured from amidship going backward of 4.02. That will be, this is amidship of 4.02. From amidship measured backward of 4.0, that will be your final LCG, and your LCB, which is 2.9, measured from amidship only up to this vertical line of 2.95. And your LCG is from amidship measured backward of 4.2. This will be your vertical line. Okay? Okay. Take note that your LCG is behind of LCB, or LCB is forward of your LCG. So look, he is behind of LCB. So what happens now? The rule says if LCG is above or behind LCB, then your vessel is trimmed by the stern, behind or above of LCB. So LCG is behind LCB. That's why he is trimmed by the stern. Okay, you have more cargo here. You take out ballast here. That's why this will go down and this will rise up. That's why you are trimmed by the stern. So it is a counterclockwise direction. That's why the reason why you have more drop up and less drop forward, because you add the vessel up will sink. That's why you add the change of drop up and change of drop forward. You subtract because the vessel forward will rise up. You will have less drop. That's why you subtract. That's why you have less drop here, and this up part of the vessel will sink. That's why you add the change of drop that you have. That's why you have more drop up of 10.71. Okay, I hope that's clear. And look at that, we have the same drop with the program. Okay, of 9.77, up is 10.71, and your main drop is 10.24. Okay, now I have another situation here. Okay, assuming that we are going to load the cargo. Okay, assuming this is another situation. Okay, assuming our vessel is a handy-sized vessel and the cargo for trimming is 1,000 only. Okay, for capesize is 5,000. For Panamax is 2,500. For handy-size is 1,000. For mini bulker is 300. Our vessel within this range, so we have to trimming for kind of vessel is only 1,000. Okay, now assuming our drop here is our density is 1.017 and our density is at our final operation is 0.17. Okay, this one is loading only. There is no discharge of ballast. Assuming that the foreman, upon reaching this mid drop of 9.96, they stop the loading operation and ask the chief officer and the surveyor to take a drop survey so that you will know how many cargo to load for trimming. Okay, so he wants to know the recommended cargo for trimming. So at this juncture, when he reached this drop or even kill, he said, "Chief, I stop loading, and can you please compute for the remaining cargo for trimming?" Okay, so the chief officer and the surveyor agreed when they take up the drop that even kill they have forward is 9.96 and up is 9.96 and mid is 9.96, starboard and port is 9.96. Now, take note that the trimming for this kind of vessel is 1,000 metric tons. So 1,000 metric tons. Take note of this TPC, initial TPC. I put it here. So 1,000, you divide it by TPC, that will be 27.96 or roughly 0.028 meters. Okay. So what you do here, for example, you want to know. Okay, so you 1,000 divide it with your TPC, that will be your 27 meters. You divide it by 100, and this is centimeters, you divide it by 100, this will be 0.28 meters from your initial drop of 0.96 you add this what you call the sinkage, okay? So you add this one equals plus your sinkage. This will be your final departure. So approximately when you load this one. So with this 10.24, you place it here. 10.24. And your final recommended cargo per loading for trimming is 1006.8 instead of 1000. Assuming this recommended, we will follow this one. So you put round it up, so we'll put 1007. So 107. Okay. So what happens if you load 1007? Look at the mid drop is 10.24, which is the same with your final departure, and your sinkage is 0.28, which is the same here. Okay. As you pre-computed, you have already computed your sinkage here, because assuming you will load 1000, but here approximately the recommended is 1007. Okay, so once you load 1007, then go to trim holes 2. You go to trim holes 2. Take note that the recommended cargo to load is 1007. Your initial drop of even keel here and 0 trim. For example, your trimming hold is 1 and 4. Okay, put 4. And here you have the same figure of remaining cargo to load. So how much are we going to load here in 1 and 4? But you will ask, what is your trim? Okay, our plan, according to the our initial, we have to make a trim of, make it 0.94. Okay, so I make here 0.094. Okay, so he will now give you the figures of how much to load in number 1. So number 1 is 824. So put here 824, and to load in number 4 will be 183. Okay, 183. And what will be the final drop? The final drop will be, forward is 9.78, up is 10.72. This is your trim holes 2, and your program in for number 6. You have here number 1 is 824, and number 4 is 183, and you have your LCG for its corresponding hold. Then your total cargo or your departure drop will be, forward is 9.78 and up drop is 9.72. Your trim is 0.94, and you have a 0 deflection, which is also the same here, only that 9.77 and this 10.71, but you have the same mid of 10.24. Then you have a 0 deflection here. Okay, the same drop and trim table. Okay, just take note, trim table, you have your the same recommended cargo to load 1007, your holds 1 and 4, and your weight of cargo 1 is 824, 4 is 183. Now, assuming that upon looking at the trimming table in your loading manual, that the correction forward and up of bolt number 1 is this one, and up is 3.3, negative 3.2, forward is negative 27, And number 4, forward correction is 2. Put this one. And up correction is 55.6. This is only my guess or approximate because I don't have the exact figures of the trimming table. Okay, I just give you the procedures how to do it. Now this, then after you have put this forward correction, then your drop forward will be 9.77 and drop up will be 10.71. Your main drop is 10.24. Your mid is 24. Your trim is 0.94 and you have zero deflection, which is the same exactly with this figure. Okay, then go back. There's another solution here. Take note, if you want to load first in number 4, so though you will have a good trim before you loading number 1. So number 1 is 824. Your correction is negative 27, 2.7, and up is negative 3.2. And number 4 is 183, and your correction forward is 2, and up is 55, 56. Okay? First you have, this is your initial drop of even kill 9.96, 9.96. After loading 183, this will be your drop after loading 183 is forward 10 meters, up will be 10.98. Carry this down, then you will have to load number 1 of 824. After completed loading this figure, your forward drop will be 9.77 and up drop will 10.71. Your trim is 0.94 and your main drop is 10.24. Okay, and then you have a zero deflection. Okay, take note, guys. This example only is when you're loading holes 1 and 4 and you're not discharging ballast. This is another situation. You're only loading your cargos in hold 1 and 4. Okay, 1 and 4. Okay, 1 and 4 only loading. But in our example, you are loading cargo and discharge ballast here. So there are two different situations, but I'm just showing you how to do it. Okay, I hope you like this program. If you like this program, please share and subscribe, and please don't forget to click the notification bell. Thank you for watching.